Unit 2, Lesson 1, Notes 1, Equations. Write verbal equations. An equation is a mathematical sentence that contains an equal sign. To write an equation, identify the unknown for which you are looking and assign a variable to it. Then write the sentence as an equation. Look for words such as is as much as, is the same as, or is identical to that indicate where you should place the equal sign. Translate each sentence into an equation. Be sure to identify a variable or to define a variable if necessary. A. 7 times a number squared is 5 times the difference of k and m. So I'm looking for where the equal sign would go in. And if you take a look, I have 7 times the number squared is 5 times the difference of k and m. So that word is where our equal sign will go. So let's take a look at everything beforehand. 7 times a number squared. Well, we don't know what this number is, so let's define a variable. Let's say, let x equal a number. Okay? 7 times a number squared. So that's 7 times our number squared. That's where we put our equal sign. 5 times the difference of k and m. So I know there's a 5 in here. And I know there's a difference of k and m. So difference of k and m means k minus m. So k minus m. However, it's 5 times that difference. So this has to go in parentheses. And that's it. Let's take a look at C. The 2 plus the quotient of a number and 8 is the same as 16. So again, we need to define a variable. We'll say let x equal a number. You can use any variable you want. Actually, let's change the variable. Let n equal a number. Two plus the quotient of a number and 8 is the same as 16. Is the same as is where our equal sign is. So is the same as. All right. We have 2 plus the quotient of a number and 8. Quotient is referring to division. So n divided by 8. So 2 plus the quotient of a number and 8 is the same as 16. Go ahead and try B, D, and E on your own. And let's take a look at the bottom at G. A rule for the relationship between certain quantities is called a formula. These equations use variables to represent numbers and form general rules. Translate each sentence into a formula. I'm going to skip to G and let you do F on your own. In a right triangle, the square of the measure of the hypotenuse C is equal to the sum of the squares of the measures of the legs A and B. All right, so we are given variables. We don't need to define them at all. I went ahead and made that a little bigger here. So we have a right triangle. The square of the measure of the hypotenuse C. The square of C. The square of C. We write that by saying C squared is equal to, that's where our equal sign goes, is equal to the sum of the squares of the measures of the legs. So the sum of the squares of A and B. So A squared plus B squared. You should recognize this as Pythagorean's theorem. Solving equations. In an equation, the variable represents the number that satisfies the equation. To solve an equation means to find the value of the variable that makes the equation true. The process of solving an equation requires assuming that the original equation has a solution and isolating the variable with a coefficient of 1 on one side of the equation. Each step in this process results in equivalent equations. Equivalent equations have the same solutions. Solve the following equations. So here we're going to practice solving our one-step equations. Letter A, C minus 22 equals 54. We need to use our inverse operations. To get C by itself, we are going to add 22, which is the opposite of minus 22. And what we do to one side, we need to do to the other. So we have C equals, add those two together, and we get 76. Let's jump to C. Negative 4a equals 48. Well, negative 4 is attached to a by multiplication, so to get rid of it, we need to divide by negative 4 on both sides. And we get a equals negative 12. Letter D. 18 minus negative f equals 91. I'm going to go ahead and rewrite this here. 18 minus negative f. We can rewrite that as 18 plus a positive f. I will not subtract, I will add the opposite. So instead of subtraction, which we have up here, instead of subtraction, we can change to addition, but then we need to change the sign of the following term. So our negative f becomes a positive f. That'll help us solve this equation. So let's go ahead. To get f by itself, we have a positive 18, so we need to subtract 18 from both sides. We get f equals, and 91 minus 18 is 73. Try E and F on your own, and let's look at G. Negative 2/3 h equals negative 22. There are a variety of ways you could solve this equation. I think the most efficient way, when you have a fraction in front of, or as a coefficient, and you need to get rid of it, what you can do is you can multiply both sides by its reciprocal. So we have negative 2/3 as our coefficient of h. So what we're going to do is we're going to multiply both sides by negative 3/2. And yes, bring the negative sign with you. So multiply by negative 3/2. Those end up canceling to be 1. They're multiplicative inverses. And I'm left with h equals. Well, negative 22 times negative 3/2. If we went ahead and did this by hand, we'd have negative 22/1 times negative 3/2. Negative 22 times negative 3 is positive 66. 1 times 2 is 2. And this equals 33. Now you could have just written this in your calculator. Your negative 22 times, in parentheses, negative 3 divided by 2. And you would have also gotten 33 as your answer. Let's skip right down to letter K. Letter K is a little bit more complicated. Here we have a negative 1/2 minus a equals 5/8. So the first thing we would want to do is get rid of this negative 1/2. To get rid of it, I would add 1/2 to both sides. That cancels out, and we have negative a remaining. So make sure you bring down that negative sign. It did not go away. And then we have 5/8 plus 1/2. Well, you could do this by hand, or you could add it in your calculator. Doesn't matter either way. I'll show you by hand off to the side. 5/8 plus 1/2. 1/2 needs a common denominator, which is 8. And 4/8 is the same as 1/2. So altogether, this would be 9/8. So negative a equals 9/8. Remember, there's an invisible 1, or negative 1, I should say, in front of that a. So to get rid of it, we're going to divide by negative 1. So we have positive a equals 9/8 divided by negative 1 would just mean we have a negative 9/8. I want you to go ahead and try the rest on this page by yourself. Okay, let's switch gears a little bit and talk about distance. The formula distance equals rate times time, or D equals RT, expresses one of the most frequently used relations in algebra. When using this equation, it's important to keep the units straight. Use the distance equation to solve the following problems. So this first problem, which takes up the page, is a 3-step problem, and we're going to do all 3 of these together. For vacation, Tom drove to a beach that was 300 miles away from his home. He made a rest stop when he was 2/3 of the way there. It took Tom 4 hours to get to the rest stop. In miles per hour, what was the average speed that he drove for the first 4 hours of the trip? Okay, so we know the beach was 300 miles away from his home. He made a rest stop when he was 2/3 of the way there, and it took him 4 hours to get to the stop. Well, with the trip being 300 miles from his home, we need to figure out how far away 2/3 was. So we need to figure out what 2/3 of 300 miles is. Well, 2/3 times 300 would give us 200 miles. So we stopped at a rest stop that was 200 miles away. Okay, so now we have our distance. Our distance equals 200. And we have our time. We know that it took 4 hours to get there. So use our formula. Distance equals rate times time. Distance is 200 equals, we don't know the rate, but our time is 4. Let's solve this equation by dividing by 4. 200 divided by 4 is 50. So we know the rate, I'll just write it down here, was 50 miles per hour. Due to heavy traffic, Tom was only able to drive at 25 miles per hour for the rest of the trip. How many hours did it take for him to drive the remaining distance to the beach? Now remember, the total trip was 300 miles, and he already drove 200. So to find how many miles he has left, we would subtract 300 minus 200 to get the remaining mileage, 100. So our distance equals 100 miles. Okay. We don't know our time, but we know our rate. 25 miles per hour. Let's go ahead and plug that into our formula. Distance equals rate times time. 100's our distance. Our rate is 25, and we don't know the time. Divide both sides by 25, and we get 4 equals time. So 4 hours it took him to drive the remaining distance to the beach. On the way home, Tom decided to go a different way to avoid traffic. This route was 30 miles longer than the trip to the beach. It took him 6 hours to get home. So we know it took him 6 hours, and the only clue we're given is it's 30 miles longer than the trip to the beach. And we're trying to find his average speed in miles per hour. Well, the trip to the beach in total was 300 miles. Plus our additional 30, that gives us 330 as our distance. So distance equals 330 miles. We have time, which equals 6 hours. Let's use our formula. distance equals rate times time. 330 equals rate times 6. Divide by 6. And we get 55 equals the rate. So 55 miles per hour was his average speed. Let's jump ahead to D. A passenger plane made a trip to Las Vegas and back. On the trip there, it flew 432 miles per hour, and on the return trip, it went 480 miles per hour. How long did the trip take take if the return trip took 9 hours? So we have two different things we're talking about. We're talking about a trip there and a trip back. So we know the trip there was 432 miles per hour. And we know the return trip went 480 miles per hour. We also know that it took 9 hours for the return trip. So we have more information right now for the return trip, so let's start there. We can go ahead and label this. We'll do return trip. And then we'll go ahead and put trip there. So let's take a look at what we know. Okay, the return trip, the rate is 480 miles per hour. And we know the time it took was 9 hours. The trip there, we also know the rate, and this rate was 432 miles per hour. But that's all we know. So let's find the missing information on the return trip first, and then we'll use that information to help us figure out the rest of this problem. So let's use our formula. Distance equals rate times time. We don't know the distance, but we know the rate is 480 and the time is 9. Multiply those together, we get a total distance of 4,320 miles. So I know the trip to Las Vegas from wherever this person was 4,320 miles. When they go home from Vegas, it's still going to be the same amount of distance. So that distance actually carries over to the other half of our problem. Now we have a rate and a distance, and we can end up answering how long the trip there took. So let's go ahead and do that, again using our distance formula. Distance equals rate times time. This time our distance we have, so 4,320 equals 432 times time. Divide by 432. And we get our time as 10, which means the return, or the trip there, took 10 hours. Go ahead and finish the rest of these problems on your own.